Welcome again to this simulation practice exercises in Pro 2. As you see in the process flowsheet window, there is a distillation column already built. This is from the column module. In the column section, you have a distillation module, that is a distillation taken here, and there are inputs and there are outputs. This is already a run program. That means it's already made. The program is successfully run. Now, what are the parameters? Input, number of trays are 8, RVR minimum 1.75, and 1.75, and a reflux ratio actually I have taken approximately at 1.5. Okay, so what are the, let us see what are the components I have chosen. Okay, number one, units of measure, initialize, and then I have taken SI unit here. That is what I have done. And the components, what are the components we have? Methanol and water. It is from the default bank, default most commonly used bank. I have taken these two here. They are ready with this in this bank. And we have, and what is the thermodynamic property I have taken? I have taken thermodynamic property as chosen NRTL as thermodynamic property. So what are the inputs specified in this here? Temperature is 293 Kelvin. That means it is in the subcooled phase. 20 degrees centigrade, so 20 plus 273, and pressure is 1 atmosphere, and flow rate I have given individual component flow rate as 14,460 kgs per hour, 10,440 kgs per hour of water. Then I have in the distillation column, going to the distillation column, there are number of trays 10. I specified 10 here because in between, that means inside the column we require 8 trays. So one is condenser and one tray as per the Pro 2, they will also be specified as number of trays. So number of trays is taken as 10, and pressure profile, top tray pressure is this. Per tray pressure drop, we are assuming there is no pressure drop. And feeds and products, tray number 6 is our what you call product, and what we are expecting the overhead, roughly it is a rough figure, that is 14,000 kg per hour. And we have performance actually. So what is the number one specifications one, column 1 spec 1, composition of the component methanol on a wet basis is 97%. So if I go to this place, I selected stream here, and then S2 here, in that I click here, and there is a composition. So if I take flow rate, it will be different. If I take composition, I select which component I am looking at. I am looking at methanol in the top product. So that is what I have mentioned in the mole fraction. So it is 0.97. I have specified it as 0.97. And the second specification, I have chosen it as stream, not stream column. I went to reflux ratio, and I have selected reflux ratio, and on the mole basis I have specified it as 1.5. Now this is column 1 T1 duty of the heater condenser. These are the variables. Okay, right. So as it is, if I run the system with the given data, will it run or not? Okay, so that is, first of all, that is the first step which I am trying to see. So if I run the system, I run the system. So as per the specification, 97 mole percent, I got 97 mole percent of methanol in the top product. So that is our intention here. Now next one is in the bottom product. Definitely the methanol composition is very less. You can see here only 2.9373. So this is what is the bottom. And column, what is the column? So if you can see here, in this column, the main important thing, what is this, is the column summary. So if I choose this here, tray 1 at the top, it is condenser. The heat which is removed is minus 40.9740. In the bottom 10R, it is reboiler. heat supplied is 46.1404. That is, it is positive in nature. Okay, so there are heat duties here. Heat is removed this much, it is added this much. This is what we are trying to look at. Now our case study is what if I change the reflux ratio, my composition or my purity will differ, but what will be its effect on these heat duties? That is what is our intention. So our intention is what is the intention is intention change reflux to see how the QC and QB vary. Okay, this is what is our intention. Okay, so this is what is our intention. So what is our intention? Intention is this. Change reflux ratio. I think I have to correct this. This is change the reflux ratio. It is not rate. It's actually reflux ratio. Change the reflux ratio. Change the reflux ratio and check how the heat loads at the condenser as well as reboiler vary. Okay, I think my purpose or our question is clear. Now go to input, go to case study, because I have already built here something. I will remove them first. I will remove them. I will say cut. Yeah. Okay. Yeah. So let us see in this param1 param1 changes. What is the parameter? So if I remove this, say okay. 1 minute. I'll remove this. Say okay. Again come back. Now see, this is fresh. Now we'll define the case study. Parameter param1 changes which parameter? This is which parameter? I am going to column parameter reflex ratio. What we have specified is in the specification 2, column 1 spec 2. So I choose this and I see this. How many cycles? That means how many iterations you are looking at. Suppose say let us say around 10 cycles. Okay. Base case value means already I've given 1.5, but okay, I can also give here 1.5. And what could be the step size? So step size would be, I intend it to be as 0.5. Okay, that means starting from 1.5 with a cycles of 10, reflex ratio will vary, and according to the reflex ratio, how much will be what will be the variation in QB and QC? That is what we are trying to see here. So reflex ratios, first one is 1.5, second one is 2, third 3, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. That means up to reflex ratio 6, there will be change in the reflex ratio, right? So which, now coming to the results here, which parameter in the results, which parameter I want to see? This parameter, column, heat duty, first one is condenser. I take this condenser here. Next, again, now insert. Now second one is also column, heat duty, now reboiler. Okay, now say okay. So this is what is my case study. Again, let us see what did I do. So in the top section, that means here I have given which input specification, which input variable, which input data can be specified. That is what we have given. Here you can only give a change in the input you have specified. You cannot give changes in the inputs you have not specified or you have not given as a manual entry also. Results, in what results you are trying to see the variation with reflex ratio, that is what you can actually see. So say okay. Now because we have done some changes, let me save it, restore input data, and then go to express and then run. Now the program is running. Now I want to check the table which I have created. So I go to output, go to table. Now I remove this table first. Okay, How do I remove this table? Remove this table name. Remove this table name. Uh, okay. Now go to table. Create a table now. The table is reflex ratio versus Q Q QC is the first, and reflex ratio versus QB is the second. Now see, this param 1 is the reflex ratio. Add it. Results 1, these are the results. Okay. Now say OK. Now you say OK. Now it is available. Go to tables, view the table. So this is your table. You can see parameter 1. What is param 1? Reflex ratio. What is result 1? QC. What is result 2? QB. Okay, even then, sir, this param 1, result 2, we are also forgetting what are those. So we can do one thing there. Go to tables or go to case study, go to input, go to case study, change this param 1 as reflux ratio. It is not allowing us to give space actually. No, as it is, we have to go as it says. So it is a reflux ratio. Result 1 is QC. Result 2 is QB. Now hope it is okay. Now say okay. Again restore input data and run. Now go to output, go to tables, and then again view. Now you can see the changes here. Reflex ratio, QC and QB. As the reflex ratio increases, the heat input in the reboiler is increasing. I think you can see here. We said up to 10 values, right? 1.5 to 6. So there are total iterations are 10. And QC also is C. You can actually see what is happening to the QC also. Okay. So there is a variation in QC also. Now copy to this, copy to clipboard, and then you can do one thing is that open an Excel file. Open an Excel file where you can actually store the results. Yeah, so I'm storing the results, and then here come here and then just paste. So this is what your results are seen. Hope it is clear up to this point. We'll also see how to plot in Pro2. So go to the plot here and then remove all the data here. Yeah, now you see it is already ready. See, I am saying plot name, so figure 1. Okay, and plot title reflux ratio versus QB and QC. So go to data. Now there are some things here which you have to understand. So x-axis, click x-axis. There is reflux ratio. Now say click on RR, add. Click on y-axis 1, click on QC, add. Click on y-axis 2, click on QB, that is add. So update here. Now say OK. Say OK. Now again go to plots. Now view plot. Now see this plot. This is the plot which you will actually get to know. This is with respect to reflex ratio at the what do you call x-axis up to 6.5. You can see the values was only up to 6. Our value is only up to 6. And then so this is the QC. As the reflex ratio decreases, QC is actually increasing. You can see this. QC is actually green color line. Sorry, QC is blue color line. So QC, as the reflex ratio increases, QC is decreasing. As the reflex ratio increases, QB is increasing. You can see this. There is a, you can see the legend here, blue color and green color. Okay. So with this, I end this session. Hope you have learned what is that, what is the intention I made. So the intention is to see RR versus QC is number 1. There is a plot here, and another one is another one is RR versus QE. So these are the two things which we actually hear. So these are the two results we have tried to obtain using case study analysis. Okay. Okay, see you in the next exercise. Similar exercise can also be done in various simulation exercises. Take care. Bye.